Yo, Fleurs, I hope you're all doing well. Thank you for coming. It's good to see you guys. I'm glad you could make it. Um, yeah, it's a bit of a late show tonight because the power schedule changed. So we were originally going to do a normal time, but because this power schedule changed, Mr. Sensible just said, okay, we can still do it later. So we're doing it later. It's good to have you all here. Thank you all for coming. Before I go on to Discord with Mr. Sensible, I'm just going to say hi to everybody in chat. PJ Cruikshank, thank you for coming, mate. Good to see you. Jeff Conkel, hello. Ryan S, good to see you too. Michael Khan, yo, how's it going, man? Moxie7, good to see you too. Paula, thank you for coming. Bye, will you? Glad to have you here. Mr. Sensible Live, hello. Original D-Rose, hello. Glad you could make it. Soundless Banana Cam, thank you for coming. It's me again. Hello. Lumpy Guest in a Vacuum. Good to see you, mate. Thank you for coming. Yannick Dazinger, you rock, mate. Thank you for coming. Glad you could all be here. And then we got Godzilla. Haven't seen in a while. It's good to see you. Pure Medicine. Hello. Thank you for coming. Glad you could make it. And Richard G. Yeah. So, guys, please, if you haven't already, please do share the show. Hit the likes. It does help to get out to a further audience. And I'm glad you guys could make it. So we got 34 votes so far. Accelerating Earth is nonsense. 88% say yes, 12% say no. Really weird. Yeah, Mr. Sensible just contacted me and asked, he wants to talk about this accelerating Earth thing, which I thought, okay, is really weird. And then I see he's saying Mr. Sensible versus FLatzoid, and it's like, okay, maybe he's fighting for accelerating Earth. I don't know. We'll see. Although accelerating Earth is actually a globe claim, so it's going to be interesting to see what happens. Hey, Face Reality, good to see you too. Coral Opal, thank you for coming. Glad you guys could make it. So I'm going to... My mouse isn't working too well with me tonight. I'm going to head over to Mr. Sensible's live stream and see if I'm allowed to go in. Maybe I think I have to go into the live waiting room. Maybe later. But it's good to see everybody here, and I'm really grateful for everybody being here. You guys rock. Let me leave him a message. Hi, Mister. I'm here. Okay. We'll see if he's gonna just move me over to the other room. Where is the page? There we go. Okay, so we'll see if he moves me over. YouTube, good to see you too. Thank you for coming, mate. Okay. It's a Sensible Live. I can't hear him now. Okay, I can't hear Mr. Sensible at all. I don't know if he's muted on the side or what's going on. And I don't know if I don't want to overtalk him if I unmute myself. But let me try and unmute myself and see what he says. Hi, Mr. Sensible. Sorry, I can't hear you at all. The sound's not coming through to me, unfortunately. Don't know what's going on. I'm going to drop out and come back in and see if that's going to work. Channel locked. Let's try again. Waiting room. Yeah, guys. This is why I'm not really such a Discord fan. Nope. No sound at all. Sorry about that. Just no sound. I have no idea what the hell is going on. Maybe it's my settings again. Let's see if I can set my settings. I'm just going to see if I can... No, I don't hear him at all. Here we go. Put 3 here. Nope. Realtek. This is where it's supposed to work, but it doesn't want to. Through the TV. Nothing. Voice changer. Nothing. Okay, let's go back through the auto deck. And this is supposed to work, but no. Nope, still don't hear you at all. Do you think it's possible that you can rather send me a link to... Well, can it only work on Discord? I don't know. Let's see, maybe my settings have changed on Discord itself. Voice settings. Hello. Testing 1 2 1 2. Testing 1 2 1 2. Okay. Seems to be working. The inputs are not working. There we
Dora.
go. There we go.
Hello. You can hear me.
The settings
What did you do?
The settings on Discord has changed. I haven't used Discord for such a long time.
You stopped messing around with it. Did you know it works?
I'm always using Ellemnet.
Right. Anyway, good evening, Zoid.
It's good to have you.
It's good to speak to you. It's been a little while, hasn't it?
Yeah.
A little while. Oh, sorry, just to say, Cygnus TSP says that I've got the loudest keyboard ever. Yeah, I've got a nice mechanical keyboard. It's the way to go.
Wow, look at the
lovely to
bulk
type
of
on.
that thing.
Yeah. So yeah. How are you? How's the family and how's FLatzoid treating you?
Yeah, it's going good. Just very busy. You know how it goes.
Well, I've seen you've been doing a lot and lots and lots and lots of streams.
Yeah, I practically have a stream every night. I just take Tuesdays off, so
Tuesdays.
That's about it when I do have off.
Yeah. But are you off this Tuesday, or did you have something lined up? I thought tomorrow.
Usually,
was that Wednesday?
Usually, I'm off on tomorrow because Michael's usually streams tomorrow, but he can't stream, so I might maybe do a little short stream tomorrow. We'll see. It depends how often.
Okay. Well, I did want to talk to you, as you know. It's actually about a couple of things, but the first one was the one which I mentioned to you and you posted as part of your description of the video, was this whole thing of Dell and his upward accelerating Earth. Now, I don't know what your position is on that, so that's why I wanted to talk to you. So it might be that we 100% agree about it. So I just wondered, can you explain what it is? Sorry, not accelerating.
He says it is. I'm saying it's not.
Okay. Well, I'll have to violently agree with you then. Well, there's a first.
So it's not much of a debate then.
Well, perhaps you can just tell us, where is he coming from? Because I have heard of this on the old Flat Earth Society sort of bulletin board forums. That was one of their theories, was UA, universal acceleration. Everything's accelerating up for some unexplained reason.
Yeah, it's actually based on globe rhetoric, the equivalence principle from general relativity. That's what it's based on. So it is actually globe rhetoric pushed, just with a flat disk.
Well, can you? I know that this is not something you believe. You've made that clear, and that's fine. But can you just explain a little bit about what it is he believes, to your understanding?
Well, he can't really make up his mind on what he believes, but he definitely believes it's accelerating. He claims the reason we have pressure gradients is because if he takes a water bottle and accelerates in a car, it displaces to give the densities of the mediums more denser to the back because of acceleration.
Yes.
Yeah.
The same as with helium balloons in the car going forward, but
with the helium,
other balloons going back.
Yeah. So he correlates that and say, let's turn it vertical, and that's why it's Earth accelerating upwards, which gives our density gradients. And then he fights.
I mean, that would be, if you had Earth as as a disk of some sort that was accelerating up at 9.8 meters per second, that would give you the same effect as gravity. So you would now I know you're going to dispute the thing about
Relative
density
density, yeah.
disequilibrium, but yes. So if it's accelerating, not just traveling at a velocity, but accelerating at 9.8 meters per second, then we would, sat in this chair would feel exactly the same. Jumping and then landing on the ground would feel exactly the same. Falling off a cliff would feel exactly the same.
Yeah, but you see,
Unfortunately,
his
you go.
argument is, though, the reason relative density disequilibrium doesn't work is because when in free fall with a water bottle, whatever, the density tower, it doesn't separate.
Right. Sorry, I'm
So
just adjusting your sound volume
yeah,
because I've just been told you're a bit quiet.
and they
Yeah, go on,
said you,
carry on.
and they said you very loud, so I've suggest yours as well.
Okay.
Okay, but anyway, they claim when they drop a bottle with density tower in free fall, then it doesn't mix, so therefore relative density doesn't work. You know the old globe rebuttal that you
Yes,
guys give.
yes, on the
But
vomit comet and whatnot.
yeah, but when we try and explain it, they all accelerate at the same rate. He doesn't buy that. He doesn't understand how inertia works. He thinks everything should still, even at free fall, still show the density properties, which is false because if something is accelerating at the same rate, one's not going to have more force than the other. You would agree with that? Thanks to inertia.
I would agree with that. I mean, when that bottle is in free fall, if it's one of those density towers with different liquids, there's no reason, if you gave it a shake, there's no reason for it to sort itself back out until you finish that free
Exactly.
fall, in which case gravity will have its effect and cause the different layers to sort again.
No, but you see, that's what I'm saying. It's not with me. It's not gravity. With you guys, it's gravity. But simple physics does dictate that it does accelerate at the same rate. I mean, this is measured. It's observed. I mean, you would agree with that. But with Dowell, he claims no, um, the things don't fall at free fall. He's claiming the Earth is rising up to meet it, so it's decelerating. So if we drop a bowling ball, the bowling ball's not falling. We're rising up to meet the bowling ball. Uh, so we don't see things fall. We don't observe things
Well,
fall.
I know that there's I've forgotten who it was. Was it Neil deGrasse Tyson? No, it wasn't Neil deGrasse Tyson. It was one of the others was sort of saying that the object is not falling. It's the
Veritasium,
no, no,
Hauser,
no. I can't remember who it was.
Brian Cox.
Whether it might be. Yeah, I think
Brian
that
Cox.
was Brian Cox who
Mm-hmm.
said that. I've actually got a brilliant video, not mine, which explains with a bendy, stretchy graph. It's hard for me just to explain just like this, but a bendy, stretchy graph which shows as an object is moving forward in space and time, or space time, when you're near a great mass like Earth, which bends space time, even though it's traveling in a straight line, it will appear to, in the case of a bowling ball, to drop. But it's hard to explain, and I
It's
can't really
equivalence
argue it
principle.
right
It's
now.
just equivalence principle. That's all it is.
But there's a massive, massive problem with his whole upward acceleration anyway, because whether Earth was created eventually following a big bang and there was some sort of energy imparted in it then, or whether God said go on upwards, whatever it is, that's a constant velocity.
Mm-hmm.
Is whatever the speed is, every second later, it's got to go 9.8 meters per second faster. So something would have to be applying more and more and more energy.
Yeah, but he's
Like
he's
what?
trying to explain it as you. Let's take. I call it swing ball Earth. You know when you take if you've played swing ball
Yes,
before.
swing ball.
So it's practically just a bucket of water, you could say, where the centrifugal force is forcing the force outwards to the bottom of the Earth, and that's what gives the constant acceleration because you're changing vectors constantly.
Yeah, there's no such thing as centrifugal force. It would be centripetal force. If you're traveling in a straight,
Centripetal force is inwards, centrifugal force is outwards.
but it isn't an actual force.
It's
If
a
I was
fictitious
traveling,
force, yeah.
yes, I'm
Mm-hmm.
traveling forward at great speed. If I'm yanked to the side, it will feel as though I'm being pushed the other way. I'm not. I'm being pulled off my course.
Mm-hmm. Exactly. But
Yeah.
that's the thing. So he wants to. His argument is moving causes moving. So you know,
South African does Scottish.
you're just retarded, you know. Yeah.
Yeah, so I don't know how to explain it. So not only do you have to have an increasing amount of force applied, it wouldn't take too long before we approach the speed of light, and we can't go beyond that.
Mm-hmm.
Also, if that was the case, why aren't we getting close to the moon and the stars that are above us?
Mm-hmm.
Unless they're also accelerating away, which actually then means you need even more force.
And what are they
To prove all
accelerating
that.
into? That's also a weird thing.
And where from?
Yeah.
Yes. So basically,
What's the energy?
his whole universe is shifting. Well, that
From
way.
yeah, from where to where, with what energy, what caused energy, we don't know.
Well,
That's the weird thing.
Look at this. Mr. S and FLatzoid agree.
Mm-hmm. It's
Dell's
weird.
Dell's Dell's wrong. Dell's
It's
wrong.
weird.
But
But
you see that sorry, go on, carry on.
but I say it's really weird because I did try and explain it to him, but he just doesn't want to accept actual measurable physics. So it's really bad. I mean, even if he wants to have his centrifugal force, he requires a physical force to have that centrifugal force present, because you
Hold
need.
on. Forgetting the whole thing about whether centrifugal force is a force or not, because I know a lot of people can't sort of get that. But
Mhm.
okay, let's go with centrifugal force. What is Earth spinning around?
I have no idea. It's probably tethered somewhere on the North Pole, I guess.
Bloody big string.
So you guys have gravity to hold you guys to the greater track than the sun. I don't have a clue what he's holding because he doesn't claim gravity. So pixie dust.
I don't know. It's strange. I've had a super chat, Zoid. It is a polite one. It's from Second Best Bob. Just super chatted £10. Thank you, Second Best Bob. Can I please ask FLatzoid why I'm blocked from his channel? I'm always polite there, and I've even sent him super chats. Shrug. I
One of
don't know
my.
if you noticed it.
I didn't even
Second Best Bob.
notice. I didn't even notice. Probably one of my mods must have blocked him. I will go and check out Mr. Bob.
Well, thank you for the super chat, Bob, and there you go. Zoid's going to check that out. Yeah. Yeah. So I picked up on this whole thing with Dell because I know that Rachie has been talking about it as well. Is it that she
She
accepts what he's
agrees.
saying, or she
She
agrees with him? Does she?
he says constant. She says accelerating. So they agree it's both moving
Oh,
up, but she's at a constant where he's an acceleration. That's where the difference
now,
is
hold on.
between them.
Which way round? Rachie
Raichi's
said,
acceleration, Raichi.
okay,
So she would
so 9.8 meters per second per second.
per second going faster and
Yeah,
faster.
yeah.
And Dal is a constant.
Well, she's right. In order for it to work, it would have to be per second per second. Because it's like when you go in a car. If you suddenly put your foot down, you get pushed back into the seat. You reach whatever the speed is you're going to drive at, then you're not pushed back any further. It's the acceleration that makes you feel pushed back or pushed down if the
Yeah.
Earth was accelerating upwards. So she would be right that it would have to be accelerating. If it was a constant speed for the first second, yeah, you've got 9.8 meters per second
Per second, yeah.
of down. But the next second, if it's still at 9.8 meters per second, you're no longer accelerating. There's no reason to be forced downwards anymore.
Yeah,
So he's wrong big time, basically.
but the problem is this is based on globe rhetoric, though, because your globe claims the same principle.
Go on, explain that.
Equivalence principle.
Well, it's equivalent. Yeah, it's the whole thing. Like if you're in an elevator, do you know if you're going up and down, or is the elevator going up and down? If you're in a sealed box, that was it. A sealed box on a rocket, like an elevator. The rocket goes up at 9.8 meters per second. You will be able to stand and walk around, but you don't know. Is it that you're being pulled down, or is it the rocket and the floor that's going up? They are equivalent. You would not, if you had no windows, you can't see any surroundings. You'd have no way to tell.
Yeah, but that's what I want to ask then. Okay. So on your globe then, every way is going, so the floor's pushing up on your globe, based on the
Well, it's the
equivalence
equivalent
principle.
of, isn't it?
Yeah. So,
But the Earth's not getting bigger. It's a globe. If it was,
but that's what I'm
it's a
saying.
globe.
So,
So,
so
so
how
someone in
does one explain
Australia,
that? So
yeah.
that's what I'm asking. How would
Um,
someone explain that though?
I guess that's all the bendy space time, the curvature of space time. But like I said, I have a brilliant video. I will send it to you, Zoid.
Oh yeah, that'd be great.
It's a actually unless no, it's probably about 5 or 6 minutes long. Basically, this guy has a graph, and you can imagine he sort of puts a picture of an apple there, and
I
you
know who
can
you talk.
imagine it.
I know who you're talking about. The
So it
asylum.
travels along a straight
He's the
line.
asylum
I
guy.
I have no idea. I can't remember the
He's a
guy's
bald
name.
guy.
I have no idea. But then he bends the graph basically,
Mm-hmm.
and so it looks as though
It's going straight. It's curved.
it's still starts traveling straight. But when he draws another line, when you unbend the graph, it looks as if the thing is falling.
Yeah, but
So I think that's where we're coming from with that.
and then
Sorry, go on.
but then I'd like you to go watch a channel called Dialect. Or I think his name is Dialect. I'll send the link for you as well, where it
Okay.
explains the metric tensors and how space and time are explained, and showing that asylum guy is actually wrong in the way he explains it. And
Well,
there's a few
I'm
channels that explain it
I'm
that
not a
way.
physicist or a theoretical physicist, but this bendy graph is probably quite a childish way of thinking about it, but it enables you to really
No,
picture
because he puts an X and a Y. He
what's
puts an
it.
X and a Y. So he's putting the
Yes, but
time.
he's
Timing
actually
is.
got a winder. He winds this winder, and the whole graph bends and stretches
Yeah.
as an equivalent to the curvature in space time. So the apple that you're letting go of still exists through space time, but it's even though it's going straight, it's following a curved path, as in it's going down.
If you want, we can
But I
always.
will send you. I will send you the
Awesome,
the
yeah.
video
If you want,
because
we
it's
can
really.
always debate space and time, though. Because we don't agree on that, though.
Well, we're not going to. I guess we're not going to. So do you not think that space time bends?
No, because it's concept. It's
Well,
just
you'll have
conceptual.
to
It's
argue the
It's a
toss with that,
mathematical concept, though. It's definitely not
which you
physical.
can photograph.
You can't You can't photograph mathematical concepts.
Well, that's why it's not just a mathematical concept. It's a physical thing. You can. Sir Arthur Eddington had his famous experiment where he photographed stars near the disk where the sun would be during a total eclipse, and they were out of position because the light had been bent
Wasn't an
by.
experiment. And
Well,
it's
it was an
correlation.
observation. It was no, it was an observation.
So it's not an experiment then.
It's an observation. It's a fact.
Yeah, but then it's not
It was.
then it's not an experiment then, because you first have to
No.
observe the natural phenomena, then you have to have your hypothesis,
Okay.
and you have to
Okay.
manipulate
Well,
the variable.
right. Well, let's stop there. So first, you have to. What was your first one? You said.
Observe natural phenomena. So
Right. Okay. So we know what that field of stars looks like. We've got endless photographs of that field of stars. Each star is in a certain placement. So that's our natural position. What was your second step?
create a hypothesis based on your natural observations.
And
So,
Einstein
yeah.
did. Einstein hypothesized that the mass of the sun would be able to curve space-time so that the light from stars passing nearby the disk of the sun would be bent, so the stars are out of position. So that was his hypothesis.
But he did that hypothesis before the observed phenomena, correct?
Well, no, he always knew where the stars were. It didn't matter which stars. He would say, if you had, hold on, if you have a field of stars, okay, we know where those star points are, right? I mean, they'll move, but they never move in relation to each other, not visibly anyway. And his hypothesis was, if you put a large mass in between the stars and you, then some of those stars' positions would then move. That was his hypothesis.
No, but like I'm saying, you've skipped the first step. He first made his hypothesis, which is a prediction, and then observed the phenomena, which is backwards. You first observe the natural phenomena, then you make your hypothesis, and then I also want to ask, how did he manipulate his independent variable?
Right. let me just go through this again, right? He hypothesized that light passing near a massive object would be bent. Okay. The sun is a massive object. So if you have a time, you can't see stars next to the sun because it's too bloody bright. So the only time you'd be able to see it is during a total solar eclipse when the stars appear as well. But you've got the disk, the black disk where the moon's covering the sun. So if his hypothesis was correct, light gets bent, stars would be the stars that are close to that sun would be out of position. They would be bent by the mass of the sun. Their light would be bent by the mass of the sun. Sir Arthur Eddington realized that at a certain date and time there would be a total solar eclipse. So he traveled to the location. You know the pattern of stars that as they exist. Let's say, just for the sake of argument, I have no idea which sort of stars it was, but let's say it was Orion, okay? And you knew that the sun would be eclipsed as it passes close to the belt of Orion. We all know what the constellation Orion looks like with the 3 stars in the belt. So anyway, you have the solar eclipse, out come the stars, and the belt, the spacing's wrong. So it was hypothesized and it was tested. The hypothesis holds true. Now, it's possible there's some other explanation.
So it's not
That's
scientific.
why science doesn't.
So we can say it's not scientific.
No, that is science. No, that's science.
What has he
but you
manipulated?
have to come up with another explanation.
He didn't. No, that's correlation.
What do you mean?
That's just correlation. If they got, I mean, you can get people. Let's say Nostradamus. He made predictions. Was that scientific?
No, he pulled stuff out of his ass.
Yeah. So just like that, you can do correlation-based predictions. Doesn't make it scientific. You have to actually go and manipulate the independent variable to know that's the cause.
Yeah.
What's the cause for light bending?
Okay.
What's the cause for the light bending is the claim.
Hold on. You said about manipulating the independent variable.
Yeah.
You look at those stars over there that are so far apart, they are still that part. So they're still the correct distance apart. You look at the ones that are just passing by the disk of the sun, being eclipsed, suddenly they're not far apart. They're not the right distance apart. Sun goes on, the next night you look at those same stars, they're back to their correct position. Their light has been moved.
Yeah, but I'm saying what's
so
the
that
cause
was a prediction.
for that? What's the cause for that?
The curvature of space-time caused by the mass of the sun. And it's not just that, though, because he also predicted that light from far galaxies and light from far distances could be bent around galaxies, and there is such thing as an Einstein cross, where you can see a quasar and it appears 4 times as a cross because its light is being bent both sides around the mass of a galaxy. You can see those photographs.
Would you be able to give me the hypothesis for this? What the cause, what the IV was in DV, because it seems to have multiple causes.
No, it has one cause that we are aware of. Okay, we've always got to be careful. Einstein had his theory that supermassive objects would bend space-time, and so the light path would be bent. That was his theory. Okay, until we were able to find any evidence of it, that's all it was. Sorry, his hypothesis, beg your pardon. Until we were able to find evidence that supported it, that's all it was. Sir Arthur Eddington photographed that, and the stars were out of position by the predicted amount. So that means his hypothesis so far is good.
Has anybody else? Has anybody else managed to get the same result as Eddington?
Well, I couldn't name them, but it's been done more than once. But also there is, let me find you a photo of an Einstein cross. I've got one here.
Because like I said, so the cause for bending space-time, the cause for light bending is space-time bending. And the cause for space-time bending is mass.
Yes, mass causes it to bend. I'm just trying to get this.
Okay, so let me get straight. Mass causes nothing to bend, and a concept created by man for a reference to bend. to show a physical
Hold
light
on. Say that
bending.
again. Say that again.
Space is just available ability. That's what space is. It's just availability. Correct?
Available ability.
Availability. That's space. You would agree? It's just.
Hold on. There's an Einstein cross. So I'm not sure. This is in Pegasus. It's a quasar that appears 4 times because its light is past this galaxy in the middle, and so you get 4 paths of light from the same object being bent.
How do you know it's just not separate light though? How do you know it's just not separate light though?
What, separate objects, you mean?
Yeah.
Well, I mean, you get an object emitting light. The light shines in all directions, doesn't it?
Mm-hmm.
Yeah. If I had a round globular light, switched it on, it lights up in every direction. But there's an object in the way. Now, some of that light is passing to the left of it and is curved towards you. Some of it's passing to the right and is curved towards you. So you're seeing it, the same object, from more than one direction.
But light travels in straight lines though. If it's diverging away,
yes, and it does.
It's not going to go towards you.
No, it is traveling in a straight line. It's traveling in a geodesic. The problem is that the substance of the universe is bent. And here, if you didn't like that one, because it's...
But that's the thing, the universe isn't substance, it's free space, it's available space.
The fabric of the universe, whatever that fabric is.
What fabric?
Well, that's in the widest sense of the term.
That's what I'm saying, 10 to the minus 17 Tor is hardly anything, it's available space. It's not physical.
We're not talking about... 10 to the negative 17 Tor is hardly anything, but that's just a number of atoms. That's not what we're talking about. We're talking about dimensions getting warped.
Dimension of free space, of available space. So in other words, that availability you're saying is physical.
Here you go. There's an Einstein ring. That is one galaxy that's the light of which has been bent as it passes the central object. So that's not multiple objects. That is an object, a galaxy.
How do you know it's just not refracted there?
Well, it's basically bent by the mass.
Yeah, but what about diffraction?
Yeah. Hold on. If it's diffraction, what's it diffracting through?
Exactly. That's what I'm saying. It's not my claim.
Yes, it's not diffraction.
You guys are making the claim that it's just you making a claim that it's scientifically validated, correct? That this is a scientific experiment when they took this photo. Correct?
Well, that's just an astronomical photo. There are many astronomical photos of Einstein rings and Einstein crosses.
And would you say what he postulated to be is fact that it's that?
Sorry, say that again.
And you would say if he postulated that's the reason for that ring, that's fact that is the reason for the ring. In other words,
well, he
proven then that's what
he predicted that if his ideas were correct, then if you had a galactic-sized mass, then further objects would have their light bent. That was a prediction from his idea, his hypothesis, and then we found it. So it's always possible, Zoid. This is the whole thing about science not proving. It's always possible that there's some other explanation or something else in conjunction with his explanation.
That's pseudoscience. That's pseudoscience. That's science.
Hold on. What do you?
You see, the thing is, science is, like we say, an empirical method. It will prove the effect, and it will never change. So if I take heat and I use heat to boil water, it will always cause water to boil, no matter if I do it tomorrow, today, or yesterday. Or if someone else does it, heat will always cause water to boil. You would agree? If you put enough thermal energy into water, it will boil.
If you put enough in, yes.
Great. So,
as we know, atmospheric pressure or the pressure the water is under will affect that. So, if your theory was if I apply heat, this water will boil at 100 degrees. You test it; it boils at 100 degrees. Unfortunately, you then find that if you go up a mountain, it boils. It would take a much higher temperature for it to boil.
Less temperature.
You weren't wrong.
It takes less temperature to boil. In a vacuum, it takes less temperature.
Yes. Yeah, beg your pardon. You're right. Quite right. And pressure cookers the other way. But the point is, you weren't wrong, but you needed to expand your theory. So your theory saying if I apply this much, it will boil at 100 is correct. But then if you change the pressure, you will need a different amount to get to boil. So you weren't wrong, but you refined your theory.
That comes with systematic experimentation after your hypothesis. So once I've already got my hypothesis, heat causes water to boil. I've validated that. Then it comes systematic experimentation. How much heat do I require to boil? Do I need less water? What kind of container do I need? How much heat do I need? That comes with systematic experimentation. But that doesn't invalidate that heat causes water to boil. Now, you can have a control at how much atmospheres, you can say, causes it to boil. But do you think putting water in a vacuum causes water to boil? Or is it just degassing?
Well, you're not at absolute zero, so there is some heat there.
But you do understand, if you put water in a... Let's say we just stuck water in a vacuum chamber.
If you take the air pressure... Yes, that's right. You take the pressure right down, it will boil away.
No. Degassing is not boiling.
Well,
there's a big difference between degassing and boiling. With boiling,
but you're sort of getting away from this thing with Sir Arthur Eddington.
No. I'm giving you a point on science because you're claiming Sir Arthur Eddington is science, and I'm trying to show you it's not scientific because there's no manipulation of the IV, so it's just correlation based.
But there is. If you look at those stars a little later on, a few hours later, because the sun's gone, the eclipse has finished, the sun's gone, the stars come out, you will find that the position of those stars has changed back to what they normally are.
Well, then
during the eclipse, when the light was passing close to the sun, the light from the stars was bent.
Okay, then
and you cannot deny that. There's a photograph.
Okay,
then there are photographs.
Yeah, then I can do exactly the same and make a prediction. God sticks a magnifying lens when there's a solar eclipse around the sun's corona, and therefore the lights are out of position. I've taken a photograph. It proved it. I've taken a photograph. It's proven it.
You're saying that it's refracted.
Yeah, God put a magnifying in front of the sun's corona, therefore the lights were out of place.
Okay. There's another theory then. So we got Einstein's theory and we got God's bloody great magnifying glass. Okay, that's fine. Okay, listen, that would be absolutely fine to postulate that as a possible explanation. But there are lots of possible explanations. Then you have to try and rule them out.
Okay, but there's a photo showing this now. So
showing the magnifying glass or just showing the result?
Showing the result.
Showing the result, yeah. So then you'd have to think, well, hold on. Einstein said it's because it's close to the sun. FLatzoid said it's because it's a big magnifying glass refracting the light. So how else could we test it? That's science.
So how did you test then Einstein's predictive theory?
Well, because of the same theory, you've got things like this Einstein's ring and the Einstein cross.
Which I said God stuck a magnifying glass in front. That's why we get it.
So. Well, I mean, just saying God did it isn't very scientific is it?
And just saying space-time did it isn't very scientific either. That's why that's what I'm trying to explain to you. To go through science is an empirical method. You have to manipulate the IV to know the cause. If you don't manipulate the IV, it's not scientific. It's pseudoscience because you're just correlating based on the belief.
Well, no, because we can see that galaxy here in this ring has had its light bent. You look at another galaxy, a similar sort of distance away, that does not have a supermassive object in the way. Its light isn't bent. There's your IV.
No, that's not IV. It's a different location. You're looking at a different location. If you say you're looking at a different galaxy, correct?
Yes.
How is that changing the IV?
Because light traveling a certain distance appears as a galaxy shape. A light traveling the same distance but with a massive object in the way gets distorted.
I think you're missing my point altogether there.
I don't think I am. I think we're getting into the whole IV-DV thing.
Yeah, because that's what science is. It's a method. You have to manipulate the independent variable so you know it's the cause. Just like heat causes water to boil. You can test that straight through. It's empirical. It's proven
But
that heat will always cause water to boil. It's proven.
I have manipulated the IV with whatever that star was, Sir Editing was looking at. As I said, let's say it was Orion, just for the sake of argument. I could take endless photos of it night after night after night. The pattern of the stars will always be identical. Okay? I get the solar eclipse passing just in the right place close to it. It gets distorted. That's my independent variable. My independent variable is when. Hold on. My independent variable is when I took a photograph of Orion.
No, that's false. You observed the natural phenomena. When you looked in the sky, you saw the light bending, correct? Now you want the cause for that light bending. So that means you have to presume a cause for the light bending, which you would say is space-time bending, correct?
Well, we'd say it's a supermassive object in the way, or a massive object in the way.
So how did you manipulate your IV, your independent variable, to validate that of being the cause for what you're observing?
Because I looked at it when the object was there and when the object wasn't there. When the object was there, it was bent. When the object was not there, it was not bent.
So magnifying glass then can be validated?
Well, magnifying glass, your God glass, could be another explanation. But isn't it funny that this God magnifying glass is only there at the same time as the eclipse sun?
Yeah, weird, eh? Almost maybe like it's magnetized to the sun or something.
Okay.
But that's what I'm making it as ridiculous as possible.
You're just pulling South African shit out of your ass.
But I have to make it as ridiculous as possible to show that it's not an experiment. That anybody can just use correlation and say it's science when it's not science. That's what pseudoscience.
Right. I mean, we're going to go round in circles. But from my point of view, to recap, Einstein had an idea. He had a hypothesis. He made a prediction. Someone went out and tested that prediction and found that prediction was fulfilled. There may be another explanation, but his prediction has been tested in many ways, including predicting things like Einstein rings and crosses. They have been found. Now, it's always the possibility is another explanation, but it's going to have to fit the available evidence more closely than Einstein's theory.
Okay, I got a super chat for you though.
Please.
Looking is not manipulating, dummy.
Well, you got your jug of water and you apply some heat to it. That's not boiling. You look at it again a bit later. It's boiling. You have manipulated the time that you looked at it. So applying a blowtorch to this will not make it boil instantly. It's going to take a couple minutes or however long. So there's your independent variable. Some time has passed, and I look at it again.
That's false, because even if you looked at it or not looked at it, do you think it would still boil?
Yeah, but you haven't established the fact. If I apply the torch to this, it's not boiling. If I don't look at it again, even if it is boiling, I don't know that it's boiling until I look at it again. Oh, it's boiling now because I left it 5 minutes.
It will definitely boil, even if you don't look at it, because the cause is not. Looking at it's not the cause.
No, looking at it is not the cause.
It's the heat that causes water to
boil.
But
unless you take that measurement, looking at it is the measurement. I am measuring it.
Looking at it is an experiment. Looking at it is part of the experimentation. Observation.
Yes, that's what I'm saying. It's an observation. It's a measurement. A measurement could be taking a temperature, taking a sound reading, looking at something. Has it gone red or whatever the hell it is? Those are all observations as part of the experiment. So our experiment, boiling this water, yes, we're applying heat. We need to allow some time, and we need to actually check it every now and then. It's not boiling. It's still not boiling. Oh, it looks a bit hotter. Now it's boiling.
Okay, so let's say you didn't add any heat to it, and you looked at it, and you walked away, you come back, you look again, it didn't boil again. What did you manipulate?
So if I haven't applied any heat, I look at it, go away, come back, look at it, and it's still not boiling.
Yeah.
Is that what you're saying?
Yeah.
So you asked me what have I manipulated? I haven't manipulated anything.
Great. So looking at it's not a manipulation. It's just an observation based on experimentation. The cause would be the heat. So that's
Yeah,
why.
I've taken 2 observations, but unless you make the observations, you're not going to see if any manipulation has had any effect or not.
Great, but you still had to manipulate the cause. Hence, if I had heat, it boiled. If I had no heat, it did not boil. So what was the cause for that observation to take place?
What? Sorry, the observation that the water is now boiling.
Yeah.
Well, our theory, our hypothesis is that it's the heat.
Yeah, exactly.
And
So
that's,
you
yeah,
manipulate
yeah.
the heat. So that's why let's put it back to editing thing then. What was the manipulated cause for that observed phenomena?
The location of the sun.
So location of the sun is cause. How did you manipulate the location of the sun?
By checking the pattern of the stars the night before, during the eclipse, and the night after. So they were in position A the night before. During the eclipse, they were at position B. After the eclipse, they were back at position A.
So correlation, not cause. Then, like I said, you didn't manipulate anything. You just observed.
Yeah, but actually,
at a
yeah, but you
different
could
time.
say you could. Well, you just claiming correlation. Well, you're saying that water's boiling because I'm applying heat, but how do you know? That's just correlation.
Thermodynamics
It is. It is a correlation.
No,
it is a correlation.
No, it's causation.
No, it's. Yes,
I can prove it's causation because I can give it heat, and it happens every time I add heat.
Yeah, well, I can prove that it's the mass bending the light, because every time you look at a solar eclipse, if the stars are in the right positions, you can see that they move.
Yeah, you're seeing it. You didn't manipulate it. You didn't.
Of course, you manipulate it.
You didn't manipulate anything. You just looked.
Yes.
You observed. That's all you did.
All right. So you don't actually have to physically wiggle. Was it Riley's going on about wiggling the independent
Physically,
variable?
you have to manipulate something to
No,
know
you
it's the
don't have
cause.
to
You do.
Of course, you don't.
Yes, you do. How do you know it's the cause if you don't manipulate it?
Do apples rot if you leave them on the side for 6 months? Yeah.
Yeah,
But
entropy.
you don't do anything to make them rot. You apply time. You go back every day and look at it. Okay, you take your measurements, and then after 6 months, you find it's a collapsed mass of stinking rotten fruit.
Entropy, yeah. Now let's
Yes,
say
but the point
apple,
is, you
let's take
haven't had to physically do anything. You don't have to physically do something. Often you do, but you don't have to.
You've just observed the natural phenomena with the apple rotting after 6 months. Okay. Now you want to figure out what's the cause for the rotting of the apple. Okay? It's the breakdown of the enzymes, let's say, would be the cause. Now you go and you manipulate that. Would you, let's say, go and freeze the apple for 6 months? Would it still be rotten?
Yes, you could try. That's what you would do. You would try to rule it out. Is it because it's just in room temperature? Hey, let's stick it in a very low temperature freezer for 6 months. See if the same happens. That's a manipulation. Yes.
Great. So then you would know. Then you would know if it's caused or not.
Yeah, but I mean, you just said it's entropy. It's stuff basically deteriorating, collapsing, falling apart.
Yeah.
Yep. So we look at another apple, leave that one 6 months. That one does the same. Mm-hmm. And then look at another apple. We've looked at 100 apples. All of them, after 6 months, have collapsed and rotted away. Okay, so you have made lots of observations. So your prediction that if I leave an apple out in 6 months' time, it will be mush. Well, we've tried it 100 times, or however many apples we've done. It's always held true. Not once has that apple not rotted, apart from the time we kept it in the freezer.
Yeah, but like I'm saying, so this is where systematic experimentation comes in. Let's take 4 different apples. The one you're going to freeze, the one you're going to stick in a humid place, the one you're going to stick in the sun, and the one you're just going to stick in a very dry place. And then after the 6 months, you come and observe what has changed between the 6 apples. What have we manipulated through all those different experimentations? The environment. Correct? So the environment at play towards the apple is what we manipulated. So we would be able to know, this is what caused the enzymes to break down, and that's why we have the rotting apple. Scientific. I can validate this because if I go and do it tomorrow again, I know I will get exactly the same result because I know what caused the breakdown of the enzymes.
So if I can jump in then, if I look, if it's a total solar eclipse tomorrow, if I look at that total solar eclipse, I know that stars that are very close to the disk of where the sun is being eclipsed will be out of position.
Yeah, but
That's
that's
just
just
and
observing.
I've looked at 100 solar eclipses, and every time stars. Yes, but you're observing the apples. You're not doing anything with them. You're just putting them on the side. I'm not doing anything with the eclipse sun. I'm just looking at it. I'm looking at the apples. I've looked at 100 solar eclipses. Always, that stars that are very close by get shifted out of position. I looked at 100 apples. Always, after 6 months, they've rotten if they're just left out.
Yeah,
There's
but
no difference.
there's a big difference because I physically went and manipulated the environment the apples were in. You just went and looked at the stars and said, I just observe again, therefore I believe it's this, so therefore it is. I got another super chat that explains it to you. Thank you very much.
Okay, and then
Spocky
I've got
says,
some as well.
Okay.
Go ahead. You go
say
first.
they are taking unproven theories, treating them as fact, and then building on top of them, not science.
So again,
They're taking unproven theories. So, in other words, looking at the sky,
well, there's no proof.
treating
It's a theory, but yeah,
treating them as fact, and then building on top of
there
them.
is fact.
That's not
There is
science.
fact. Right,
What's
right.
the fact?
There is fact. The fact is that star's light was out of position. Whatever the cause, that star was moved.
So
That's a
whatever
fact.
the cause, so you don't know the cause.
Yeah. Whatever the cause. Yeah. I mean, if Einstein hadn't come up with any explanation, someone just decided to take that photograph, and they knew the astronomical positions, and hold on, that star's out of position. That's a fact. It appeared on the photograph out of position. Einstein had an explanation. More than that, he didn't just look at the photograph and says, "Oh, I know why that's happened." He had predicted beforehand that it would happen, which makes it a lot more powerful.
Okay. Like I said, how about Nostradamus? And just quickly, Nostradamus also had predictions that came true. Okay, he predicted it.
Wow.
So was it proven because he predicted it?
Nostradamus came up with all sorts of vague and poetic claims that people see. Like, for instance, I just say, Zoid, I don't want to get into the whole 9/11 thing, but for instance, people then said, "Look, Nostradamus predicted it," but no one said beforehand, "Look at that prediction. That means that those towers are going down." No one did. They fitted it afterwards. That's no good. You need a prediction that enables you to, right, he's predicting that perhaps this day, this week, or this month, this is going to happen. So we can have a look, see if does it happen? Does it happen? No, it hasn't happened. It's no good looking at it and saying afterwards, he told us that was going to happen. Well, you're just fitting it in. And even if he was right, it was totally useless prediction because no one identified what it was predicting beforehand. Do you have any more super chats to read? Because I've got a couple as well.
You can go. It's fine.
Okay. This is from David Molinarolo. Thank you, David, for super chat for $10. Space-time can be explained like this. If I say, meet me at 5 p.m., your question would be where? That's space. If I say, meet me at the town square, your question would be when? That's time.
Mm-hmm.
Yeah, but that's what I'd have to say, though, Dave, that's not space-time. Space-time, all one word, is a bit different.
But that's based on the metric tensors. Yeah, he's more or less right in very rudimentary terms.
But he's also super chatted $5 Australian, so it's Australian and US dollars, I think he's super chatted. Oh, no, beg your pardon, it's someone else. Someone called My Perspective. Hey, Keith, unblock me too. You're always saying everyone is welcome.
People like to be blocked. I'll check him out as well.
Okay. Oh my goodness. Oh, he super chatted again. The same thing. Unblock me too, please, Keith. I seem to have got 2 super chats from you. My Perspective saying the same thing. Very kind. Perhaps FLatzoid will unblock you twice.
I'll block him. I'll unblock him, block him, and unblock him again. How's that?
I've got a message from someone called Nike or Nikki Spitz. Oh, Nikkei. I see. You they super chat me the other night, and I didn't get the pronunciation. Nikkei. Sorry, Nikkei. Why do you stream the same time as Toon? Well, if Toon had said to me, "Hey, I'm streaming tonight at a certain time," I might have said, "You know, I'll wait a couple of hours," or the other way round. But we can't keep up with everyone who's streaming. I mean, you must have the same thing,
Yeah.
Zoid, that you're streaming. I think someone said QE is streaming as well. I don't know if he is.
Yeah, he's
But
streaming, I think, now.
yeah,
Or in an
so
hour. Or in an hour.
you're going to get clashes, I'm afraid. So what I say, Nikkei, is watch both. Watch this one and then Toon, or the other way round.
Download the one, listen to the other tomorrow.
Yeah, yeah. And the last super chat in the queue is from 3Ron for $5. It's so cute. FLatzoid thinks he knows the scientific method. Time is absolutely a variable. This is demonstrably. Demonstrably, or I guess demonstrably so.
We can debate that as well. Please manipulate the independent variables as time for me, please.
Well, time. Let me think of an example. Well, actually, just a really simple one is if I took that apple before it's gone mouldy, I let go of it, it doesn't fall. Not for that fraction of a second. I'll give it a couple of seconds and it's down on the floor. You have to allow time. You're boiling water. You apply heat, as I said. It's not going to instantly boil. You have to apply time.
Sorry, so time was the cause for the water to boil and time was the cause for the apple to fall?
No, it's an independent variable.
No, it's pseudoscience is independent variable. It's not, it's a control. So that's what I'm saying. Manipulate time for me, please. What does time cause?
Time allows other things to happen.
So it's a control then. If it allows other things to happen, it's a control. It's not an independent variable. It doesn't cause things. Time does not cause anything. It has to be an independent variable. It has to be a cause.
It's an independent variable. It's an independent variable. I mean, if you want to Google it, you'll find that time is
pseudoscience. Yeah, pseudoscience.
Oh, so all the references on the internet then that say time is an independent variable, they're all pseudoscience. Yes.
Usually based on psychology and genealogy and stuff.
A subtle blend of extreme violence and psychology.
Okay, no, but like I'm asking, if you prove to me now that you can use time to cause something. You can't, exactly. Time can't cause anything.
I used time. I deliberately didn't say anything. I used time and you spoke.
You didn't cause me to speak.
Well, we would still be sat here in silence.
What caused
I didn't cause you to speak. Yeah. I allowed time. I allowed time.
So it wasn't time. Time wasn't the cause then.
It's a variable.
A control variable, not an independent variable.
It's a variable. It is a variable. It's independent in that I allow some time to pass and something happens. If I don't allow that time to pass, it hasn't happened.
How do you stop time? How do you stop time then?
You don't have to stop it. Why do you have to stop it?
Because you just said if I allow time to pass.
I see what you get. Okay, right. So if I'm applying my heat to my glass of water or whatever it is, kettle of water, if I only allow 30 seconds and then measure it, it's only got up to 30 degrees. It doesn't boil.
Heat was still the cause for that water to get hot, was it not?
Yeah, but you said heat would cause it to... No, hold on. You said heat would cause it to boil.
It does.
Yeah, but I measured it after 30 seconds and it was not boiling.
Time was the control. You gave a control of 30 seconds. That's what time was. You controlled it at 30 seconds.
Yeah, but
the duration of time was 30 seconds. So therefore, it's a control, not an independent variable.
But it is independent. If I took temperature measurements every 10 seconds or whatever, I would get a new temperature reading. And eventually, after, say, 5 minutes or whatever it is, that's boiling. But
great. So we can do the same now without heat. Will the temperature change if you don't apply any heat? We do the same. We do exactly the same.
We'll leave aside the whole business about going up mountains or whatever. But so we're in the same place. Okay, I've got a second glass of water. I don't apply heat. Every 10 seconds, I take the temperature and Oh, it's the same. It's the same. It's the same.
So not time causing anything
I
then.
didn't say time. Time causes. Time is an independent variable, as in if you allow a variable amount of time, different things can happen,
Do you know what a
which would not
control?
happen if you didn't allow that time to happen.
Would you be able to explain to us what a control variable is?
Well, hold on. I've got a super chat from 3Ron again. Thank you. Beg your pardon. They've got two super chats. From my perspective again, his name is Aaron Armstrong, the guy who.
Aaron Armstrong. Okay.
Okay. I mean, I no idea whether you blocked him or not, or whether you, when you mods did, whether it was a valid blocking or not. But I'm just passing on the super chat. And I've got a super chat from 3Ron, excuse me, saying, put heat to water for 30 seconds, not boiling. Heat for 10 minutes, now boiling. Time is absolutely a variable. The amount of time is the independent variable.
No, the amount of time is the control. Hence, you've proven my point when you said don't add heat to it. It won't boil no matter how long you wait. If you don't add the heat, there's no boiling. You can wait for eternity. It's not going to boil the water. The cause for water boiling is heat. The time it takes to boil is a control variable.
You said you can wait for eternity, it won't boil.
Mm-hmm. Because they evaporate.
Well, okay, we'll stop. But what I was going to say was, assuming no evaporation, you're going to have to actually wait for an eternity to find out if you're correct. It may, 10 minutes before eternity, suddenly boil.
Why?
Without heat. Why? I don't know. But you see, this is it. You've got to rule things out. So in fact, let just going back a bit. So your idea of applying the heat, causing it to boil, and yeah, we find that happens, that you apply a certain amount of heat for a certain amount of time and it's boiling or whatever. But unless we actually waited an eternity, we don't know 100% for sure whether a few minutes before eternity it would suddenly boil.
You do know
you cannot rule that out. I think it's damn unlikely.
You do know eternity is just a concept.
Okay, 1,000 years. Okay, so but do you see what I'm saying? That this is why science doesn't prove. You could do 1,000 tests with that, and every time you applied a certain amount of heat for a certain amount of time, a certain amount of heat for a certain amount of time, it boils. Okay, so your idea looks good, and so far we haven't seen anything to rule out your idea being correct. Okay. But we haven't tried certain other things, like waiting 1,000 years or trying it up the top of a mountain or whatever it is.
Okay, I also got two super chats quickly for you. Okay. And then I'm going to quickly answer you quickly there. Television, he says, speed up time, please.
Why do I need to speed up time?
Because you say it's an independent variable.
No, I'm allowing a different amount of time to pass before I take my measurements.
So it's not an independent variable, it's control then. And then another one from Awesome Lawson Clips. He says, how many IVs in a hypothesis?
You can have more than one independent variable, but then things start to get tricky, don't they? Because which is the variable that's causing it? Because it could be a conjunction of two variables. In fact, with our boiling water, there are two variables. It's the atmospheric pressure and it's the amount of heat you're applying. So X amount of heat at ground level is will have a different effect on that water than X amount of heat at a different pressure. Or what if you kept the same pressure, but do you see what I mean? You're balancing two things.
No.
Two independent variables.
Let me quickly explain. No, there's one independent variable. The pressure would be a control. The pressure would be a control. The heat is the is the independent variable.
What? Why?
That's why it comes with systematic experimentation.
Yeah, I'm not going to disagree with you. I'm just asking you to explain, why is the heat an independent variable?
Heat causes water to boil. Thermal energy. This is proven. Thermodynamics. Everything you use today is based on this thermodynamic principle. It's a proven fact. Heat will always cause water to boil. Now, if you change the pressure to make it boil at a lower temperature, heat still caused it to boil. The pressure was just a control.
Yes, but let's say it's now boiling at 80 degrees or whatever. Why is it boiling? Is it boiling because
the
you've applied
heat.
heat,
Yes.
or is it boiling? Yeah, okay, but I could have the same amount of if I've got the amount of heat to boil it at this lower pressure. If I allow the pressure to rise, it will no longer boil.
Again,
so my independent variable then is the pressure. Do you see what I mean?
the pressure is the control. The pressure is the control.
You've just picked one and said this one's the control, that one's independent.
Remember,
but they're both. You could have both. You could have the same, applying the same amount of heat and adjust the pressure, or the same pressure and adjust the amount of heat.
But you had heat. Now just change the pressure without
But you
heat.
had pressure.
Okay, remember I asked you in the beginning, does not adding heat and sticking in water in a vacuum chamber boil the water?
Well, what I would say with that is it's commonly regarded as boiling away.
But it's not boiling.
Okay. No. Hold on. You just asked me a question. It's commonly regarded as boiling away. What I would say, because I'm going to be open and honest, is technically I don't know if that actually is boiling or if it is just, as you say, degassing. So I'm not going to argue the toss over that, okay? Because
I can tell you it's not, though.
Well, you tell me it's not. That's fine. I've not looked into that. Whether you would say if you reduce the pressure in a vacuum chamber, this suddenly starts bubbling and then slowly disappears. Is that boiling or is it degassing?
I can explain the differences if you want.
Well, please do, because commonly it's known as it boils away in a vacuum.
Okay.
Why are you laughing?
I'm trying to think how I can explain to you. With the boiling, with the heat temperature, it creates a phase change. You get water vapor, the steam, okay? So it turns to water vapor. Correct? Because of the heat energy transference. Now,
Yes.
when you degas something in a vacuum chamber, there's no water vapor. The gas is simply escaping the water to fill the available space. It's not water vapor. It doesn't go through phase change. The gas is simply escaping the water. There's no heat involved with that.
Well, there is heat unless you take it down to absolute zero. Is it boiling at a much lower temperature?
Look, there's always temperatures. But
unless you're at absolute zero, there is temperature. Yes.
No, there's always temperature. Even in a
not at absolute zero. There isn't. By definition, there is no temperature.
It's zero, absolute, but you can't get absolute even by definition of physics. It's impossible to get naturally. You wouldn't be able to measure it, because as soon as you try to measure it, you would be in some form applying some sort of heat. But absolute zero means that all the atoms and molecules are absolutely rigid. They are not moving. And you can't get that. It's impossible. Yeah, we know. But like the point is...
Yeah, so therefore there is always heat. So therefore, we've already established you apply heat, you go to a lower pressure, then it will, up a mountain, that water will boil at a lower...
Boil. It degasses. The gas is escaping the liquid.
So why is it boiling at ground pressure? Atmospheric, 1 atmosphere.
When you add heat,
you call that boiling, but up there it's not boiling.
When you add heat, it boils. If you don't add heat, it doesn't boil. Remember, the pressure only causes the temperature to be less at boiling point, so it lowers the boiling point. That's what the pressure, because you've got less pushing against the liquids and the gases.
Well, I've just spotted. It's not a super chat. Just spotted a comment. I want to give the guy's name. From Justin Franks, says degassing is when dissolved gases are expelled. Mm-hmm. Water in zero pressure is boiling.
No,
as I said, not. I'm not going to argue the toss over that.
So dissolved gases is now water vapor. And I've got a super chat as well for you. Sensible thinks the ISS is traveling at 17,500 miles an hour.
Well, there's a change. There is off topic, but I'll quickly address it. Yes, it is. And I did a video that showed the predicted path of the ISS, and I went out and filmed it with my phone. Yeah.
But yeah.
So it's there.
But like I said, with degassing, it's not boiling. It's simply the gases evacuating the liquid, where boiling is it's going through phase change, and that's what's
Yes,
happening. It's two different
but
things.
the point. So here I am at ground level, roughly sea level. So you're saying if I apply a certain amount of heat to that water, it will boil. Yes.
Always have to apply heat.
Okay. Okay. Yes. Yes. I'm applying heat and it's boiling. Good. So if I go up to the top of Everest with my glass of water and I apply heat, will it boil?
Yes, because you lowered the pressure, so the temperature needed to get it to boil is just lower.
Okay. So instead of boiling at 100, it's boiling at say 90 or whatever the hell it would be. Yeah.
Yeah, okay.
Yeah. So I go up higher and apply heat, and it's now boiling at 70. I go higher and apply heat, it's boiling at 60, and so on until I reach a height where the amount of heat I need to apply is virtually nil. I'm still applying a tiny bit, perhaps the warmth from my hand, and it's boiling because
So there's
the
always
atmospheric
heat.
pressure there is so low.
So there's always heat
So we
present.
agree now. Okay. So now I go up higher still. I don't apply any heat. It boils.
There's always
So
heat present. There's always heat present, Mr. Sensible. Gas is moving
So
as
I
heat.
already said
Liquid
to you.
moving
I
as
said
heat.
to you. Yes, but so I applied 100 degrees centigrade worth of heat to this glass at ground level. At Everest, I applied less to get it to boil because of the lower pressure. I go higher, I apply less and less and less and less until I reach the point that just the warmth of the water itself, it will boil.
Yeah, but
So
does
basically,
it?
like an atmospheric pressure gradient, we got a boiling water versus atmospheric pressure
So
gradient.
the heat is
So
still
a vacuum
the cause.
chamber
Then.
is boiling it.
So the heat is still the cause for boiling, not the pressure. Then
Yeah, but you don't have to apply the heat.
heat
Just
is always
taking down
present.
Yes,
Yeah,
yes, heat is present, but that's
pressure's not the independent variable. Pressure didn't cause it to boil. Heat caused it to boil.
did it? So that's not boiling. I take down the pressure, it boils.
Pressure just brings down the temperature it needs to boil at. Okay?
Well,
and this
it's
is
not
also
gonna be
you
much
and this is also you assuming that there's gonna be water vapor at that temperature, at that altitude.
Well, that's what you were saying, but I mean, basically, we have two variables. We have the amount of heat applied and we have the pressure, and you're juggling one against the other. A little bit of heat and very low pressure, it will boil, or a lot more heat in a higher pressure, it will boil. Two independent variables.
Okay, and then
So I can't boil that at 90 degrees down here. So if I change the pressure, my independent variable, I am now boiling it at 90 degrees because I've reduced the pressure.
Great. I just want to say thank you. Got a super chat quickly from Skeptic. Thank you for your channel support. It just says channel support. And then Retro Bull, he says, Gerund went glurf. So it's only fair Mr. S goes flurf.
Sorry, say that again.
Gerund went glurf. So it's only fair Mr. S goes flurf.
Jaren. I said I wanted to speak to you about a couple of things. We started off with Dell. Jaren is indeed the other one I want to talk to you about because there's been a bit of a conflab between the two of you, hasn't there? What's your argument about with Jaren? With my mate Jaren? Tell me, what's he done?
Jaren.
He's not my mate.
Jaren, the guy fighting for geometric horizons. He's a globe believer, mate.
Tell us what the issue is. What's he said?
I can show my latest video quickly if you want to. It explains it quite easy.
Well, why don't you drop me a link? I'll happily pop the link into the chat. But
okay, but let me just explain it to you. Oh, anyway,
yeah, please.
The argument he gives is exactly what you guys globers give. The geometric horizon is physical. Okay.
Right.
So he's claiming horizons aren't optical. That's globe based, correct? Ooh. I pressed out by accident. Do not have permission. General chat. I hope he's going to put me in again. But wow, the guy doesn't know science even if it would hit him in the face. But thank you guys all for coming while we're waiting for him to put me in. Okay, I'm back in.
You back?
Sorry, I pressed the wrong button by accident.
That's okay. Sorry, I was just, I did hear your question. I did reply, but you might not have heard it. I said, you're taking one thing and sort of applying it in a different way. You've got the geometric horizon. If you have a ball, then looking at that ball, there is a physical horizon. Okay, a point beyond which, a straight line from your eye to the top of the ball. But what we actually see, because we're looking at that through several miles of atmosphere and you have refraction, you see something slightly different. The optical horizon. It may be a bit further or not quite as far as the geometric horizon. Usually a little bit further.
Yeah, but that's what I'm saying. He's fighting for the globe with the geometric horizon, so that makes him not a flat earther, correct?
So,
well, but that's just one of the things. That's just one of the arguments.
But I've not heard what he said. So what has he said? He said there's a geometric horizon.
Yes.
What about it?
And he says you can't debunk it. And he says science doesn't prove things. And you know what his argument is for why science doesn't prove things?
What's his argument for why science doesn't prove things?
Rocks cause waterfalls.
Oh, do you know, I did see some comment about that in some of your video, and I didn't look into it. I have no idea what that's about. But the thing with the horizon, I'm presuming that the whole thing with that is because of sextants.
Oh, yeah,
is that
sextants, yeah.
Yeah.
He doesn't know how sextant works.
So.
Remember when he went on McToons and he said, yeah, you can use the curved adjacent to get an angular reading?
Right.
So now, throwing away what an angle is.
No. I tell you what, just in the broadest layman's terms, what is an angle? Sorry.
Two straight lines meeting at a vertex.
Yep, spot on. I'd agree with that. I mean, there's different ways of saying it, but I agree with that. Yeah. So why is there a problem? We have a sextant here, and it's measuring an angle, in this case, between the sun and the horizon, yes?
Yeah, and the horizon, exactly. Yeah. So he's physically pointing at the horizon, correct?
He is pointing, so the light rays from the horizon pass through the horizon mirror, at B, and through the scope to his eye, and at the same time, we've got the light from the sun coming off the
index
the index mirror, bouncing off the horizon mirror through the scope, and he moves the arm backwards and forwards until he gets them to align properly and takes his reading. So that gives you an angle.
Yeah, so that gives you an angle. So he points the sextant at the horizon. He seeks where the sun is, and he brings it down to the horizon.
Yep.
And then he swings it left to right to make sure it is all parallel.
It's as low as possible. Yes. Yeah.
So angles in succession.
So we got an angle, haven't we? So we got an angle.
Angles in succession to the horizon.
In succession.
Yeah, that's what the principle. The sextant principle is based on angles of succession. So in other words, A and B have to be parallel to one another to give an angular reading.
Well, yeah, because light reflects with the same, is it the same instance angle? So if it hits that mirror at 45 degrees, it'll bounce off at 45 degrees, doesn't it?
Mm-hmm.
That's how a mirror works. If you're stood dead in front of the mirror, the light reflects 180 degrees back to you, doesn't it? If you stood looking at an angle at 45 degrees to a mirror, you'll see off at 45 degrees, won't you?
Mm-hmm.
So yes, you're right. You need to adjust that mirror so that the light, the path of light from the sun bounces off A, bounces off B, so it goes directly down the scope, doesn't it?
Yeah.
Because you made the adjustments. Yeah. Okay. So that's fine. So what we end up with is an angle between the view he gets through the scope of the horizon and the view up to the sun.
Mm-hmm.
That's his angle.
Yeah.
Yeah. So why is that a problem?
You just explained it can only work flat Earth.
No, I haven't.
That horizon, would you agree he's physically pointing at the horizon, correct?
He is pointing at the horizon, yes. Is he at the same level as the horizon?
Yes.
Hold on. Is he at the same level as the horizon? In this diagram he is, but he could be stood on the top of a mountain.
That's why you have height of eye correction, so you can be more accurate.
Exactly. So if he was that, as in this diagram, an absolute straight line through from his eye through the scope through the mirror to the horizon, then that's simple. That gives you the elevation angle straight off. If he's at the top of a mountain, you have to allow for that height, don't you?
Okay, but
because that's extra. That would make the angle too big because you'd be looking slightly down to the horizon, up to the sun, so your angle's too big. So you correct it back, don't you? You adjust.
Okay. I'm gonna ask you a question. No matter your elevation, altitude, are you looking straight out to the horizon when using a sextant because it has to stand parallel?
No, it doesn't have to stay parallel.
Yes,
you could use a sextant.
You don't point the sextant downwards. You point it straight ahead of you. That's the point.
Hold on. You point the sextant at well,
90 degrees.
2 things.
90 degrees.
No. Hold on. Let me answer. You point the sextant at the 2 things that you want to measure the angle between. They could be horizontal. There's no reason it's not horizontal. If, as I was saying, if in this case we're using it in the standard way, holding the sextant vertically, looking straight through it, you're looking at the horizon. Okay. If your eye, you're sat there in the water, so that your eye level is through the surface of the water, basically, then you don't make a height adjustment, do you? If you're at the top of a mountain, by definition, you're high. You're looking down towards the horizon. That horizon has gone a bit further, but you're looking down to the horizon. You adjust for the height. No, you even said you adjust for the height.
When you go onto a mountain and you look out, do you look down to the horizon, or does the horizon rise relative to eye level?
It doesn't. That you can see further. Yes.
So the horizon looks higher. The horizon looks higher when you go up the mountain. Yes, it looks higher,
but it's still downwards. Why do you make a height correction? Why do you make a height correction then?
Because the sextant, to be more accurate, requires the sextant to be on the same plane as the horizon.
No, it has to be horizontal.
Exactly, same plane.
No,
as the horizon.
No, horizontal doesn't mean that. If I could be stood at the beach, okay, looking horizontally forward, and the horizon is, to all intents and purposes, horizontal to me. If I'm in an aeroplane and I look straight forward, I'm not looking at that same horizon. I have another horizontal. It's just it's parallel, isn't it? It's another horizontal.
Horizontal.
If you have yes. What does horizontal mean? If I hold a spirit level, do I have to hold it down on the sea level? No. Or could I climb to the top? No, I could climb to the top of the building, and I've got a new horizontal. It's parallel to the ground level one.
Sorry, I have to laugh about this. You do know you're literally fighting for flat Earth here. I don't even have to do anything.
No. No, what I'm saying is, because you're saying you have to, you can't take a reading unless the Earth is flat. I'm saying, let's just say, for the sake of argument, that the Earth was flat. Okay, if I go to the building and I use a sextant, I'm not at the same level. I've taken a new horizontal parallel to that lower horizontal.
So it's parallel to horizontal then?
It's another horizontal. Every horizontal stood at this point is going to be parallel, isn't it? But the point I'm making is, if you don't even need to see the horizon, you don't need to, all you need is a horizontal, don't you?
Yeah, you can create an artificial horizon because of the sextant principle. Like I said, if you don't have that, if you don't have that horizontal baseline, it's not.
I don't need a horizontal. This is an artificial horizon,
which gives you a horizontal reference.
Hold on, no, it doesn't. That's not how you do it. Right, there's an. I'll show you then. Shall I?
Yeah, go ahead.
Can I show you? Okay. So there's, for anyone who hasn't seen one, there's an artificial horizon. You put a liquid in it, and then you've got a couple of filters to because the reflection can be very bright, basically. There's one in use. So you're looking down, and you can see the filters make, I think he's looking at the sun by the looks of it. It could be a spotlight, though.
It's usually the sun,
dim it so you can actually see it. Yeah. Okay. This is a guy using an artificial horizon. In this case, a plate with some molasses on. There is a horizontal through the molasses. We have 2 beams of light coming. Listen, I presume it's the sun. So we got a beam of light that's hitting the molasses and a beam of light that's coming down straight to the sextant, which is the normal way you would see the sun in the sextant. So he has not got a horizon to look at. not a real horizon. So what he actually does, instead of bringing the sun down to the horizon, he brings the sun down to the reflection in the molasses. Now, that means we've already established that the angle of incidence where the ray of light hits the molasses is the same angle it bounces up. Okay? So where we reach the sextant, you've got the same angle from the sun, the same angle there is twice. So basically, you take the reading, you bring the sun down, so it's reflected. It matches the reflection in the molasses, and then half that angle, and that's your angle of elevation. No horizontal whatsoever, no horizon even seen.
Sorry.
You do not need a horizon.
You just literally said, look at that horizon baseline for the artificial horizon.
No, what you aren't right. His sextant, one mirror is pointing up at the sun. Yes, the direct view. The other mirror, or looking through the other mirror, is not through a horizon. It's looking down, literally, to the artificial horizon.
Mm-hmm. And he's making them parallel to a horizontal?
No, what he's doing is he takes the measurement. What's the angle? Just as with our first example, this one, just as you're taking an angle between the sun and the horizon, in this one, he's taking an angle between the sun and not looking horizontal out from his sextant, but he's looking downwards to the reflection. But that gives you twice the angle. So in effect, that there's a fictitious horizontal where those two lines meet. So where your direct view comes just to the left of the 2 times HS, because you've got double the angle. So whereas, let's say in this one, you read it and you get the height of the sun as 25 degrees. In this one, he's looking at the same sun, the same time of day. He gets height of 50 degrees, but then he halves it, gives him 25 degrees.
Yeah,
boom,
exactly.
No horizon used.
Because he set a horizontal. That's why he made an
horizontal
horizon. The molasses is a horizontal.
It's lower than him, FLatzoid.
So?
He's had to adjust for height, hasn't he? He's adjusted by halving the angle.
Exactly, to get to the horizontal.
Hello, can you English? Look, so in this case, he's taken a reading that's twice the size. So he deducts half the reading, yes?
Yes.
In this case, the horizon is slightly down, so you deduct because of your height. And it also, I was going to say Coriolis. I don't mean that. I mean refraction. It's the same thing, but you don't need to have a flat surface. Where is his flat surface there?
He's standing on a flat surface, the ground.
Okay.
The molasses is on a box, which is flat. It's showing a horizontal baseline for that molasses. Molasses is literally standing level.
Yes, but it's not a flat Earth between here and the GP of the sun, is it? It's a little dish with a flat surface that he's just using as a mirror.
Remember when I told you how a sextant principle works? Angles in succession. You're literally showing angles in succession here. Why do you think he needs to halve it? He's
halving it because he is making the correction for the fact that his artificial horizon is way below the horizontal.
Yeah, exactly.
So where is yes?
So
I don't know why you're laughing. Because in this case, you adjust for the fact. So you don't half this one, but just for sake of argument, let's say measures that sun as 25 degrees above the horizon. Oh, but the horizon is 1 degree down. So that's actually 24 degrees elevation. That they use the horizon because it's pretty damn close to horizontal from your eye line. Pretty damn close. But you have to make corrections. This is nowhere near close, but it's a very simple correction. You just half it.
Because the angles of succession.
How about that then?
Yeah.
A bubble sextant. No horizon used at all. You establish a vertical.
Sorry, what does a bubble do? It's a level, correct?
A bubble. In fact, to be level, what does it have to be? You can say it has to be flat and level.
Would it be showing that you can make it horizontal, correct? The vertical and the
What you've got.
horizontal is perpendicular. Is that what the bubble
Do you
level
do?
is
Do
doing?
you, do you, I'm not being rude because I mean I don't know whether you would know and don't know whether you would be expected to know. But do you know what is inside that bit where it says the bubble chamber? Where I'm sort of wiggling my mouse
Guessing
with a.
liquid and a bubble?
There is liquid in a bubble,
Mm,
but basically you've got a slightly curved top to the container that that liquid is in with
mm-hmm.
crosshairs.
Yeah.
So obviously, if you're tilted one way or another, the bubble won't align with the crosshairs.
Yeah,
So in this
it's the
case, what?
same kind of that you have on a theodolite. So you have
Okay, I'll bow to your superior intellect on that one because I don't know about theodolites. So anyway, there is actually a light source in there, so that you can see the bubble. The image of the bubble reflects off a mirror back up to the beam splitter and through the scope to your eye. The sunlight, much as in the ordinary sextant, reflects off the index mirror, off the horizon mirror, and you're not even looking at the horizon, and then straight through the telescope. So instead of establishing a horizontal and an angle above it, you're establishing a vertical and an angle from it. So you do not have to see a physical horizon. You're not using an artificial horizon, and it doesn't matter a damn if there's a mountain in front of you or a valley, or whether the Earth is flat or curved. It would make no odds. You don't need it.
Sorry, so
The shape of the Earth you're standing on is not going to affect that
when
reading.
you use the bubble level and you're making it perpendicular to vertical, that would mean you're looking
Not
horizontal.
you're making it vertical. You're
Yes,
making it vertical.
so when you look through
Okay.
the scope is perpendicular to that vertical, correct?
Yes.
So
You're
horizontal
basically
then.
so you've established your vertical by making sure the bubble is properly aligned, which means the sextant is being held. The bottom yellow line that goes left to right, that path of light is horizontal. You did not need to look at horizon to establish that. You did not need to bounce it off molasses. You have established that as a horizontal from the vertical, i.e. perpendicular to it, 90 degrees from it.
Great.
So tell me why then? So if that red line coming down, that's your 90 degrees vertical, isn't it? That's to your zenith, obviously. The ray of light coming from the sun, you're measuring the angle between those two. So where they meet, so you've got red down and the yellow coming across, and let's say, just for sake of argument, that's 50 degrees off of that vertical. You haven't had to. It doesn't matter what you stood on.
It doesn't matter what you stand on because your reference is horizontal.
It doesn't matter. Yeah, it doesn't. Yeah, yes, it doesn't matter what you stand on. So why the hell do flat earthers then, Zoid, say you got to have a flat Earth because you can't get an angle from a curved adjacent? I'm not using the surface of the Earth at all. I'm not using the horizon. I'm not using the sea. Nothing. I'm just using a bubble.
Okay, when you take,
sorry, I'm getting overexcited there.
When you take the star's GP, it's on the same elevation plane, correct?
What do you mean?
So when you take a measurement to the star's GP, you need to
I don't take a measurement to the stars. No. Okay, I don't take a measurement to the star's GP. I'm using a sextant to find out the angle between that ray of light and vertical. With a bubble sextant, I've got a vertical. With an ordinary sextant, I've got a horizontal. So I can deduct the angle from 90 to give me the angle between vertical and the star. So let's say that's coming in 30 degrees above horizontal. Therefore, that star is 60 degrees off of my zenith.
Great. So
that's all I know. 60 degrees off my zenith.
Great. So when you measure 60 degrees off of zenith, you've taken your 90, you've minus the 60 degrees, and you've got
minus the 30 to give me the 60.
Okay, so that's you're saying co-altitude angle. So you've used your co-altitude angle now to get the distance from the GP of the star to you.
Wherever that star is. I don't know off the top of my head. I need to look it up.
Great.
In the almanac.
Okay, so let's say you've worked it out now and it's 3,600 nautical miles away or whatever.
Okay. Yep.
That GP from that star has to be on the same line of reference, horizontal, to where the observer is for the 90
Why?
degrees to work out, because you're creating a
Why?
triangle.
No, I'm not. No, I'm not. You've already right at the beginning. We agreed on what an angle is. It's two rays with meeting at a vertex.
That 90 you are starting off with, that's the GP of the star's 90, correct?
No, no. What I'm doing. Well, actually, no. I have my zenith. It's whatever is directly above me.
You standing 90 as well, yeah?
Well, I'm stood up.
At 90 degrees.
Yes, to the 90 degrees to the floor.
Great. And the
Aren't I?
GP of the star is also 90 degrees to the floor in its position.
Yes, but why does that have to be the same? Let me just try. No. I thought about this earlier, Zoid. Okay, right. If I'm looking at you, okay, you're the star, and I'm laying on my back, and you're absolutely overhead. You're at my zenith, yeah.
Mm-hmm.
Okay. I then turn, let's say, 45 degrees. Oh, you're not at my zenith anymore, but you're still here, aren't you?
I'm
So if
still
I
at your
roll my
zenith.
eye,
I'm still at
yeah,
your zenith because I'm ahead of you. You're just looking another direction.
I'm looking at another direction. Yeah, my zenith, because I'm round a curve, is different now because I have moved around. I now measure the angle and I find, oh, it's 45 degrees to where FLatzoid is directly above to where I am. Therefore, I now know that I am 1/8 of the way turned around. If I do another one, I'm now quarter of the way round. You're now 90 degrees off of my zenith, aren't you? Quarter of a circle. That's all we established. All we're establishing with a sextant. I've turned. In this case, how far round a circle I've travelled.
Do you think
We know how big the circle is. Therefore, if I know I've travelled quarter of the way around a circle, if the circle is 10 meters, I have travelled 2.5 meters. Boom. That's all you're doing.
Do you think I can quickly share my screen?
I
just want to quickly draw
I'm quite happy for you two, but let's see.
I just want to draw something on Paint quickly for you. That's all. If I can.
Right, I'll have to try and screen capture it. Let me just try and get this set up. It might be a bit of jiggery pokery here, because I'm gonna have to try and capture it on.
I also don't think we can go on too long. It's already almost 1 a.m. here. I got work in a few hours.
Do you know? Yes, yeah.
Oh, sucks that we had to start so late.
Yes, I mean that's true, but I think FLatzoid. One thing I do need to say.
You know, I'm just going to quickly draw it on my, and then I'll just send it to you. Then you can show it. How's that? I'm going to draw it.
Oh dear.
Mm-hmm.
Right. So you're sending me something, are you?
I'm going to quickly draw it, then I'll send it to you.
Oh, okay. I can post the image. That's easy enough. Yeah. Yeah. So I mean, the basic principle behind all the celestial navigation stuff with a sextant is you're finding how far the star is off of your zenith, how many degrees. So, okay, we can't see through the Earth, but imagine that the Earth was translucent. If you could see the star was now directly below your feet, you know it's the other side of the world. You've travelled, or your distance from that star's GP is 180 degrees, half the way around the world. Then it's converted to a distance. That's it.
But I'm going to show you.
I don't know how you're sending me. Are you emailing it me or what?
I just almost finished drawing it, and I'm going to
okay,
because I'm doing it on Paint quickly.
Okay, that's fine. Are you going to DM it to me then?
Yeah, I'll DM it to you quickly.
Okay. Well, while Zoid's doing that, let's just... Oh, my screens are jumping around all over the place here. Where are we? Just wanted to check a few bits. How many people we got in here? And I hope you're all enjoying this. I've been enjoying. I got a bit overexcited earlier on because it's frustrating for a Zoid. I mean, this whole thing, it's a Nathan Oakley thing. Say, oh, you can't take an angle from a curved adjacent. I'm not using a single curve. I'm using a tray of molasses or a bubble sextant or looking at a horizon which is slightly dropped and correcting back up to a horizontal. It doesn't matter what's between you and the GP of the object. It could be valleys, it could be seas, it could be mountains, it could be, an eighth of the way around the world or whatever. It doesn't matter, because wherever that star is, it's still got its own GP. It's over another point on the Earth.
Okay, I've sent it to you.
That's what's in the almanac. We look that up, and we know, because we've calculated. Oh, we're 600 nautical miles from wherever that GP is. Look it up. This date and time. There's the location. We're 600 nautical miles from there, which doesn't tell us anything other than we're in a circle around it.
Okay,
go on. You've got it.
Yeah, I've sent it to you.
Okay. Let me just pick this up.
This is exactly the same problem Jaron had.
Oh, I've seen your diagram. This will be interesting. I will let you explain it, and then I shall respond. Okay. Let's see if I can pay. Is it going to let me? Oh. let me save it first. Hold on. We'll be there in just a tick.
I haven't used Discord in such a long time.
Well, that's good. I was able to drag and drop it off of Discord. I didn't know I could do that. Right, so there's your image. Let me just zoom it a bit. Oh, if I look at the right window.
Great. Okay.
Okay, go on. You go.
So on the left, that's what you guys are assuming, okay? The one on the left is closer to you, okay? The horizontal line would be that red horizontal.
Well, that's okay. So just so we get where we agree and don't agree, that red line is a horizontal on both of them.
Yeah.
Okay.
Now, when
I'm going to zoom it in a bit more just so people can see it. Go on.
Okay. So when you're standing at that 90 degree, that would be that
here,
that vertical.
This cross. Yep. Okay.
You're looking up and you're measuring an angle to the star. Correct?
Okay. So I could be using the yellow line upwards, bubble sextant, and measuring down, or I could be looking at the horizon, or
no, you're standing using a nautical sextant at the moment. You're just standing on the red line.
I'm
and you're looking out at the horizon. Okay.
Looking out at the horizon, and yes, we measure an angle up, make corrections, and then deduct it from 90 to get that one.
Great. So you're measuring the angle to the star. So you would agree that adjacent and the hypotenuse is two straight lines.
It's not an adjacent and a hypotenuse.
Yes, it is.
No, hold on.
You're making a triangle.
Right. No, hold on a second. We're stood at that cross point, yeah?
Mm-hmm.
Yeah. So we got one ray going to the star.
Hypotenuse, yeah.
One ray going that way.
Adjacent, yeah.
And there's our vertex.
Yeah.
That's it.
Sorry,
that's two rays and the vertex.
The star has a GP on the ground, correct?
Yeah, well, for a start, it's not there. The star's GP would be somewhere around there.
That's why I look to the right?
Yes, like that. So that's how the star's GP would be, yes.
So would that change the angular reading?
No.
Why not?
Because the angle in both of those is between the red line and, sorry, I'm a bit colourblind, whatever colour that is between. What colour is that?
It's between white and baby blue.
Okay. So we got the line from the star to the cross, What we're measuring here is the angle between the red and the line from the star to the cross. What we're measuring here is the angle between the red and the star to the cross. The fact that the star's GP is there or misdrawn there makes no odds. All I'm interested in is that angle. Two lines and a vertex, an angle, as we established at the top of the show.
Of course it makes a difference. You would agree because the star has to be 90 degrees, correct? The star has to be 90 degrees on Earth's surface, just like you are 90 degrees on Earth's surface.
The star is, if you're stood here, it's 90 degrees. If you're stood here, it's not.
Exactly. But I'm saying, let's say you got someone standing underneath the star at 90 degrees. They'll be on the right.
So we got someone stood there.
They're looking upwards. So the star is right ahead of them.
The star is right over their head. Yes.
Great. Okay. And then you got the observer standing on the top there.
There.
Also at 90 degrees. Okay.
To what? Oh, 90 degrees to the surface of the Earth.
Yeah.
Yes.
Okay, so
Yeah.
they each got their own different zeniths.
Mm-hmm.
So he
Yep.
takes...
So person A has got a zenith that points to the star. Mr. Sensible has got a zenith that points just
straight
up there
up, yeah.
somewhere.
And you
Yeah.
take a measurement now, let's say 45 degrees to that star.
What, me?
Yeah.
Here?
Yeah.
Okay, so I have used my sextant through all our clever means, and I established that angle there. Yes.
Okay, great. Now I want to
I'm
ask you,
done.
we're minusing the 90 degrees to get the co-altitude angle, correct?
Okay, so what angle were we saying? This was 45, was it? So this is 45 as well.
Yeah, but you're taking 90 degrees of the
Yes.
star's GP, and
No.
you're minusing to get the co-altitude angle of the star's GP.
What's the hold on? What's the co-altitude angle?
The co-altitude angle is the apparent angular measurement. So the apparent angular
Of
measurement
what?
is the correction of the apparent angle measurement. So if you taking
No.
if I
Can I
take
correct
40,
you?
listen, if I take 45-degree measurement, I have to,
So
I have to
can
minus it.
we say 40 so we get 40 and 50? We don't get two 45s, just to make it clear as what we're talking about.
40.
Okay, so it's
You've measured it
45
40.
degrees up.
You've measured it
Yeah,
40 degrees. Okay.
Yep.
Now you have to take 90 degrees. Okay.
Yes, which
and
is
minus the 90 degrees by 40, which gives
Yep.
you 50 degrees.
And where's that 50 is there, isn't it?
Yes, co-altitude
Yes.
angle.
Yes.
Okay.
So what? So yeah, but I'll let you carry on. But just to explain. So what I've done is I have used my sextant, measured that the star is 40 degrees of elevation. Therefore, the co-altitude is 50, which is 90 minus the 40. I.e., that star is 50 degrees off of my zenith.
Great. Okay. So,
Okay.
does that star have a 90-degree angle as well?
That star has a GP somewhere.
Of 90.
Yes.
And it has the
Where
same...
your matey boy is
and
sat
it will
over
have
there.
the same circle of equal altitude.
What does that? What do you mean it'll have the same circle of each?
The same. It has to have the same horizontal plane. You're completing a triangle here.
No, you're not completing a triangle.
Yes, you are. You're doing triangulation. You're doing a...
No, you're not.
You're doing Sakatoa. You're doing
No, we're not. Okay.
Yes, you are.
Okay. If you're doing Sakatoa, what's the height of the star?
You can't get the height of the star because it's an apparent...
Why?
Because I've proven this with my FLAS
You
challenge.
just said you're solving that triangle with Sakatoa.
I can give you a citation that says you're doing Sakatoa if you want to.
Well, you're not. Okay, let me run you
I can
through.
give you a citation that says you're doing Sakatoa when doing...
Okay.
navigation.
Give me a citation.
Okay.
I'll give you a chance to find it. I'll just get my Discord sorted out. Hold on. I've killed Discord. Hold on. If he's still there, give us a second. Well, that is not. Hello. You still there?
I can hear you.
Okay, good. I accidentally killed Discord, so I don't know how I didn't lose you. That's good. Yeah, sorry. You're just getting a citation.
I'm just looking for... It was on my other PC. But I got it on my... I think I got it on one of my videos. Then I can find where I got it. Channel. Just quickly looking where I got it. Because they actually teach people to use using Sakatoa for celestial navigation.
I suspect if you come across a reference to it, it's in a different aspect of it, because you don't solve any. If you solve a triangle, if you've got two angles and a side, or two sides and an angle, whatever, you can solve all the lengths and all the angles. We haven't got that. And anyway, we're not interested in solving a triangle. What we're interested in, like my example, when I was on a spinny chair, all I'm interested in is how far have I turned around. I've turned around, in this case, 50 degrees. Therefore, that star is 50 degrees off of my zenith. Therefore, I know the percentage or the distance around the Earth I've travelled. That gives me a distance. I didn't need to solve any triangles.
Just trying to see what's the name of the... because they give it everything. They explain it. in Sakatoa and everything. I actually showed this to McToon before as well, but yeah, just ignore this. There we go.
Oh, you got it, have you?
It's www.staff.vu.edu. Would help if I actually put the link down there, and I didn't.
Yeah. If you pop the link in there and I'll... Excuse me.
I said it would have helped if I did stick the link down there. I just have to look for it. It's been a while.
This diagram with the two circles that you're showing anyway. I'm not referring. Even you have said that one on the left is incorrect, showing that GP of the star coming down at a funny angle to the surface. Why are you even showing that diagram? Because that's not what we're sort of saying anyway.
If you're doing Sakatoa, that's exactly what you're saying.
So is this where you're talking about? You are talking about your circle of equal altitude.
Your circle of equal altitude has to be on the same plane.
No. But is that why you're showing that wider triangle? Because that's not a GP. The GP of the star would be roughly halfway between those two lines.
I'm going to just quickly stick the video until I find it, but it's got the citation there for you. You can actually go through. I'm going to look for the actual citation. I've stuck it to you.
Hold on. I've got the video. What am I looking for? Is it the...
I'm just trying to look for the actual citation quickly, but it's on there. You can go to 32 seconds as well. You'll see it there.
Let me... Right. I think... yes, I've got it up on the screen. So it's... 32 seconds in, did you say?
You can go even to 32. It's going to show you Sakatoa. The thing is, this is they use this specifically to teach nautical navigation to students.
Sorry, 32.
I think it's 32. Where was it?
That's trigonometry review. Oh,
there we go.
What is that? The one you're talking about? Right. So what is this? Because I can't see what that says. It's quite small. Trigonometry. Yeah. The three basic trigonometry relations that we're concerned with here are sine, cosine, tangent. They're ratios of length of two sides of a particular triangle. Particular type of triangle is most useful in maths is a right triangle, one angle equal to 90. Where's it saying about this in relation to celestial navigation?
It's a whole document. This is just the one part on Sakatoa. You can go through the whole thing.
But we know what.
Look for the whole.
Okay, because we know what Sakatoa is. That's the whole point when flat earthers say you're solving a triangle. Well, why can't you tell me the height of the star then? Because using Sakatoa, you can calculate those sort of things.
No, remember, if you can use Sakatoa to get my height of my floss, then I can say, but you guys can't get that right. You know, no one has managed to do my floss challenge yet. It's been out.
I don't know anything about that.
Are you good with trigonometry?
I can muddle my way through it. I'm not going to be able to do stuff.
If I give you the
the point is this is solving triangles using sines, cosines, and tangents. You don't do that to get the co-altitude angle. The co-altitude angle tells you how many nautical miles away you are from that star's GP. That's it.
Mm-hmm. How do you get that co-altitude angle?
Well, we just done it, didn't we?
Yeah,
we just did it.
Doing Sakatoa.
Sorry, let me just... No, hold on. Where's your image? There's your image. Okay, so I measured the altitude of the star at 40, which deduct from 90 gives me a co-altitude of 50. It's 50 degrees off my zenith. So it's 50 times 60 nautical miles away to the star's GP. I haven't solved any triangles. I've got the answer.
You do know the 90 degrees you are working with is the star's 90.
What do you mean? I'm stood here.
Mm-hmm.
Okay, I'm stood here. The star is 40 up.
The star is 90 degrees in reality. Otherwise, you wouldn't get
A star is.
Otherwise, you wouldn't get your complete triangle, would you?
I'm not solving a triangle. I have solved. I have taken one angle, the measured elevation, and deducted that from another angle, from 90, to find out how far off of 90 it is. So if it's 40 degrees above horizontal, therefore by definition it's 50 degrees off of vertical. Boom, that's it. I haven't solved a triangle. I've done one simple subtraction.
Again,
that's all I want to know. And that, and now I know that. I know wherever that star's GP is, could be anywhere because I don't know them off by heart, and it depends on the time of day. But wherever it is, I am now X nautical miles away from it. I'll get my nautical almanac, look it up. Oh, there's the location of it. I'm X miles from it.
Okay, that's what. Like, going to ask you again. Remember, I asked you, are you good at trigonometry? So, if you measured 40 degrees to the star, okay, and
elevation,
we know the internal angle, some of a triangle is 180 degrees, okay. So we've taken the 90, you've minused your 40, which gives you 50. So that means it would be 50 degrees of the star, correct, in the corner, on the top.
But all we're interested in,
that would be 50, correct?
Right.
So there's your co-altitude angle without being able, without minusing.
Do you know?
Listen.
I think I can see where you guys are all going wrong. You're trying to. You've got your first angle, the angle of elevation of the star, as you said, 40. You know that the star is at 90 degrees to the Earth's surface somewhere, and then that gives you the remaining number of degrees. That's what you're talking about, isn't it?
I might have to draw this again because this is simple.
Yeah, it's simple. I don't see why you don't get this. I mean, look, you see your diagram, okay? If that star, because of course I know it's just a drawing, so the star's very close. But if that star, okay, I'm at 12 o'clock. If that star was at 9 o'clock, right over here, okay, I mean, because it's parallel light, it would appear exactly in the horizon, wouldn't it? So when I measured its elevation would be 0. Deduct that from 90, it's at 90 degrees to my perpendicular. Therefore, its GP is a quarter of the way around the world. There, at 9 o'clock.
Okay, I've given you with all the angles in.
Oh, right, you got another diagram. Okay, let's just see if I can get that one in nice and easy. Will it do it that way? No, I'll have to save the darn thing again first. One sec. This one, yeah?
Mm-hmm.
Okay. Yes, that's true. But that's what I'm saying. I see where you guys are going wrong because I'm stood here on the right. I measure the star's angle as 40 degrees. We know that somewhere on the Earth, the star is directly overhead. It's at zenith.
Which would mean it's 50 degrees.
90 degrees. Which makes 50 there. Yes. And in fact, if you were to draw a line from the star across here horizontally, that would give you a 40 up here. Of course, yeah.
So if you had to draw a line from that star now, not showing 90 degrees, would you get the same angular reading?
What do you mean if I had to draw?
Like we said on that other diagram that you had now previously that I drew, with on the right, that 90 degree wasn't 90 degrees anymore. The one on the right, the other side.
This one. Sorry, say it again. Oh, right. So you're saying that 90...
Would that still show 50?
Right.
Would that still show 50 and 90?
Yeah, of course it wouldn't, because... but this is why you guys are going wrong. You've come from the background thinking the Earth is flat. I know that's 40 degrees. You hear of co-altitude angle deducting from 90 and taking it up there. Okay? But if that was the case, if I moved a bit further away. So I don't know how many. If I move further away, so it's no longer at 40 degrees, it's at 30 degrees.
Mm-hmm.
Okay. The distance between the Stars GP and this one won't equate to the equivalent distance between there and where I've moved to.
Yeah.
Like
bring up your quick picture of your
like that.
Bring that picture.
This is why it doesn't work.
Bring the picture of your sextant up again.
Hold on. Look at my diagram. I know it's going the other way. So we've got the sun. Mr. S on the right has the sun at his zenith. Mr. S, the next one, it's 10 degrees off. So it's elevated at 80 degrees instead of 90. It's elevated at 70 degrees, 60 degrees. Okay, 50, 40, 30 degrees. But the distances between them aren't the same. But in actual fact, using celestial navigation with a sextant, every 10 degrees will be 600 nautical miles.
Yeah,
this won't work.
You want me to give you what's the linear relationship why it's flat?
Please
bring up the picture.
I'm all ears.
Bring the picture of your sextant up quickly.
This one?
Yeah. Look at that index arm. Is it curved?
Well, this here.
Uh.
Where the the readings are.
Yeah. Is that curved?
Yeah. Yes.
Is that an angular reading over an arc?
What we've got is we're measuring an angle. We're
Yeah, and is that index arm traveling over an arc?
Well, if you have a rigid object and you turn it around, the end of that object's going to trace an arc. Yes. So
great. So there's your linear distances. The distances come off of that linear arc.
Right.
You closing your celestial sphere with the bottom of that arc.
You're closing your celestial sphere.
Mm-hmm.
No,
it's your angular reading, just like the protractor. Just like the protractor that you just put on.
Like one of these?
Mm-hmm.
What about it? Sorry. Where is it? My picture I just showed you. That one.
Mm-hmm.
Yeah.
You see the bottom of that protractor, that curve, that arc? You would agree every degree measurement is the same linearly the same distance.
What's I see. So between that one and that one, it's
exactly
the same as that one. Yes, but because all that is, that's a rotation, isn't it? You're rotating around the point.
On the arc, correct. Now, that angular measurement is two straight lines meeting at a vertex on a arc, correct?
I'm on the flat Earth.
No. Yes, you on the Earth, but the angular reading is an arc. It's an opening between two straight lines.
Yeah, but I could draw this the other way, Zoid. Well, in fact, there's lots of Mr. Sensibles there who have taken angular elevation or used a sextant to get the angular elevation of the sun. Now, with celestial navigation, if I am 10 degrees away from zenith, I'm 600 nautical miles. If I'm 20 degrees, I'm 1,200 nautical miles, and so on. So why suddenly do these distances get bigger? I'm on a flat Earth, according to you.
I've explained it. So, it's that arc.
But you haven't.
You're measuring on the sextant.
So are you saying then, if each one is 600 nautical miles apart, are you saying that this guy over on the right, or this one next to him, when he took his reading, he has misread the height of the sun?
No. Straighten that curve out now of that index arm arc. What happens when you straighten it out? Will that give what you're seeing now on the bottom with that flat, not having the same linear distances anymore? If you had to straighten that curve out.
So if I distorted the image to make the curve,
if you took that curve, that arc, and you made it
bent
straight,
down each side
and you
of it,
bent it straight, what
would happen to the Earth? The Earth would turn to a sphere or a curve. Yeah.
No. You've made that arc straight now. Would you still have the same linear distances?
I don't know what on earth you're talking about.
You wouldn't, because the vertex would be at a different location, correct?
The vertex is at the sun.
Yeah, but I'm saying if you're taking the sextant.
With these rays, the vertexes at the sun, for me, starting from right to left, it's 90 degrees. The sun's directly ahead of me. I move a distance away. Oh, the sun appears to have dropped by 10 degrees. I move again. It appears to have dropped by another 10 degrees. We know that every mile you travel, every degree you travel is about 69 miles each one. So every 10 degrees is 690 miles.
Yep.
These guys are moving, so the sun's dropping 10 degrees at a time. But suddenly they're not moving, they're not the same distance apart. The distance is greater. Now, if you've got parallel light rays on a curved surface, guess what? For every 10 degrees, it will drop this. It will be the same distance around a curve.
We've all established the sun's rays are not parallel, but like I said,
they are all but
you're
parallel.
literally taking a measurement, two straight lines from a vertex, over an arc. That sextant index arc is the degree measurement you're taking. That's why you close, what I said, the celestial sphere, and that's why you have your linear relationship on a flat Earth, because that closed arc linear reading is parallel to the horizontal of the scope.
Would you like some dressing with that word salad?
It's the mechanics behind how a sextant operates, how it works. If you didn't have it, yeah.
It's a shame. It's a shame that sailors and that would disagree with you. Then people who actually use it or know how to use it.
Okay, let's say if we took that arc on a sextant and we made it a straight angle, not an arc, would you get the same readings?
Well, so instead of that curve, if you had like a ruler,
yeah. Would you get the same
readings? You could do that, but then
would you get the same readings?
Well, if you let me answer,
no, you wouldn't.
If I'm looking, let's go back to the picture.
Okay, it's getting.
So this one, right. So there's your picture. Okay, you've got your index arm. Now, if that scale that's curved was a straight line, well, quite apart from the fact you wouldn't be able to swing this, but let's make the arm a lot longer so it could swing past it. Then the actual measurements, you could have those measurements on a straight line, but they would get further and further apart.
Do you understand what's happening? So it's the sextant.
Yes, I understand what's happening. So you have no bloody idea what you're talking about, FLatzoid, at all.
Wow.
Sorry, I don't wish to be rude, but you don't.
You just validated my argument like word for word there, mate.
Is it?
Yes. Oh, but I got another super chat, and then we got to close off because it is card late.
Okay, that's fair enough. I have enjoyed this.
It was nice. I enjoyed it. It was nice and cordial.
Oh, good.
Awesome Lawson Clip says, channel support and shout out to Mr. S for coming on and being cordial. Enjoy the convo. Oh, and welcome to Flat Earth, Mr. S.
Well, thank you for the appreciation. I appreciate that. I'm not quite a flat earther yet, anyway. FLatzoid might have to do a bit more to persuade me of that one.
Well, no, I think it was a nice chat, though. I'm happy we at least agree on something, that accelerating Earth is just stupid.
Yes, yeah, absolutely. There's nothing to support it. As a possibility, it's a possibility. Only there is no evidence whatsoever to support it. And just with Occam's razor, it's not the simplest solution.
Can I ask you one question then quickly before we close?
Yeah, go on.
When someone, let's say, drops a lighter, you would say it's measurable and observable that the lighter is falling towards the ground?
So, as a cigarette lighter?
Yeah.
Yeah. So you drop an object, it falls towards the ground. Is it observable and measurable?
Yes.
Yes.
Great, okay. Dal thinks to say, no, we're making the claim that it's falling.
I see. But then we're talking about the
that principle. The equivalence principle.
Back where we started. Perhaps a good place to finish. All right, listen, Zoid, thank you very much. It was enjoyable. It was good to talk to you again, and I hope you and your family all stay safe and well.
Awesome, you too. One more super chat for you. Richard Paul, thank you very much. It says, if you truly love King Charles, Mr. S, say it's flat.
I think old Charlie Boy's all right. It's better than certain other possible world leaders who shall remain nameless. Anyway.
But thank you very much for the stream. Must do it again.
Yep, my pleasure. I enjoyed it, and I thank you too. I thank you too.
I thought tomorrow night. I mean, Wednesday is going to be Mactoon, but it's next Wednesday, so and that's on Celestial Navigation. So do stay tuned with that.
Yes. So that'd be interesting. I'll have to keep a close watch on that one then. It'd be interesting to see if he has. What I'll do is I'll let him know about this stream so he can have a look, see what he reckons.
Yeah, you can do that. Let him prepare himself.
Yeah, and perhaps it will also save a bit of time that he doesn't have to go over certain things that we've already gone over if he agrees with me, and he can perhaps take the argument further forward.
Yeah.
Okay, cool. All right, thanks again, my friend, and we'll catch up again sometime soon, yeah?
Awesome. Thank you very much.
Cheers. Good night, man.
Blessings. Guys, so there we go. That ended. Wow. I don't know what to say. Thank you guys for coming. What can I say? Thank you for all the support, by the way. I think I might have to check all the... so just want to shout out to all the support on the channel. You guys rock. You really, really do help this channel a lot. Sorry that we have to close because we did start kind of late because of the power, and I need to sleep. I got work in a few hours. So yeah, I want to say thank you guys for coming. It was interesting. I don't think he realized how bad he threw his globe away tonight, and there's quite a few snippets we'll be able to take out of there, so I think that's really great. I might send this to QE, see if he'll do a review on it, because I think it'll be interesting to see what he can come up with. But I just want to say thank you guys for coming. You guys are awesome. Really, really appreciate it all. I'll let you guys know tomorrow if I'm going to be on tomorrow, because Michael's not on. So I think I will... Did you miss the super? No, Richable. I let him read it. He says... He didn't want to say it's flat, but he did say he thinks he's better than other people. So he doesn't say he loves trolls, though. But thanks all for coming. Really, really appreciate it. I'll let you guys know in the day tomorrow if I am going to stream tomorrow night for a while. Might just be an hour stream or something then. Just because Michael can't stream tomorrow. But I'll see you guys all tomorrow or Wednesday. Anyway, many, many blessings. May the pressure be with you. Cheers, guys.